My name is Kusant Maurya. So here I start my topic and the presentation. Actually, in the real time, in the modern system, there are so many problems that we are facing in our car that are traveling on the roads. Actually, there is a due to the fatigue and the poor congestion and lot of traffic, we are not able to control the cars, and there is a lot of accidents that are happening in even today. So, as per the data that have been released last year, around 1.35 million people die and lose their lives due to the accidents that are happening on the roads due to the traffic congestion, and there is a human error also due to the fatigue and other issues that we are facing. And the traffic congestion is one of the most important problem that we are facing in today. So there is also a automation gap because of there is a lot of human intervention into the car. The cars are not automatic, so I am building this project just to automate the car and other transportation system that are being deployed in our country as well and in other country as well. So here I move on to the next topics. Next slide. That is a system objective. What are the objectives of my system? So in the first objective is it is a fully autonomic navigation system in which I am building the platform where my platform is being connected with the Google Map through the navigation and other apps. We can also develop our own platform. I have researched about it that India is also building its own Google Map, and as that map is very secure and not sharing the data with other countries. So according to that, if that is available, then we can implement that. Instead of the Google Map, I would be implementing that software which is built by in India itself. And so this is a fully autonomous navigation system. And the second is that it is there are uses of sensors and the camera and the sensors. They are acting as an input. So if there is an input, according to that they are processing the data. And so there is an obstacle detection and avoidance. If the obstacle is in front of the car, so it would detect using the sensors like ultrasonic sensor and other sensors which are present, which will be developed and would be processing according to the sensitivity of the sensor. Suppose there would be other sensors like moisture sensor, humidity sensor, and temperature sensor, and other sensor like light sensor. According to suppose there is a night time, so in that condition the sensitivity of the sensors would increase. So this is the second objective of my project. And the third objective is smart decision making. So according to the inputs of the sensors and the camera, it would be detecting the object in front of it, how much distance is there, the object, and how the speed of the car has to be controlled. So according to that, it would decide itself within a certain time limit, because there is a the time limit is very important factor in this. So as per which I am developing, I am using 50 millisecond here. I would be explaining in detail in future slides. So the fourth objective is safety and the efficiency. And as these all the features are being interlinked, so these all features will be contributing to the fourth objective, that is the safety and the efficiency. If the all feature works in a coordinated manner, so it would increase the safety and the efficiency also. Kushan, come on to the results, please. So this is the system architecture which I have posted it here, which I have explained it here. Raspberry Pi is working as a main brain of the system, and the ultrasonic sensors and all others are acting as an eye, and the motors and the actuators, they are acting as a muscle. So I have just related it to the body system, body of our human body. I have related it with this. So this is the working process, the same that I have explained in the previous slide. It captures the suppose that there is a camera sensor which is capturing the data from the in front of where it is, and then it is detecting, and the object is being detected, and the distance, everything is being calculated internally, and the processing is being done within a very few milliseconds, and then it is deciding what to do and what actions to be taken, and those actions are being taken by the motors and the actuators that are present in the car. So these are the key features which I have already explained about it in earlier, and there is a IoT tracking also that I have not explained earlier, and the wireless charging. Wireless charging is having the two main coils, and it is working on the electromagnetic induction. So the first is a transmitter coil, and the second is a receiver coil. The transmitter coil is transmitter coil actually is present in the where the charging pads are there. So the car would be standing on the head, and it would be just releasing the magnetic fields and the flux, which is the main cause for the main effects for the charging. So the receiver coil will be there under the car, and that due to the flux electromagnetic induction concept, it would be the wireless charging would be done, which is not present even today in the cars. So IoT tracking is just there would be dashboard which can be tracked from remote location also where the car is present. And there is also one of the most important factor that I would be thinking that I should mention it here, that there is a path detection also and the path memory. Suppose the car has gone from the Faridabad to Delhi location, so it would track the path, and the path that it has took in the past, it would just store it in its memory, and then in the future if it has to go to the same location, then it would just rely on the previous path.
Kushwant, audience has felt your energy, just conclude it.
Okay, sir. So I have explained it. This is a wireless charging implementation here. So I want to just show you the real prototype that I have built, and I have also built the dashboard also. There you can see it. There is a battery and the distance traveled, how much distance have been traveled, and the obstacle status, and the speed, how much speed is in the real time. So all these I have built. I would show the video. It's very small. So actually till now I have not attached the Raspberry Pi. I have attached the ESP32, and due to this I have to transport this data to the internet, and then after the cloud it stores the data, and therefrom it takes, so there is a delay of some time. So this is the performance and the graph data analysis. This is not the actual, but I have just thought of it. This may come if I would implement whole, the testing would be done. Actually there is a testing part is left. So this is the conclusion. So I have just built the robot, the bot, and the car, whatever you can say, and that is a integrated system, embedded IoT and AI, everything has been integrated into it. And finally this project is titled as a smart autonomous car system. So that's it. Thank you, everyone.
Good work, dear. Yes, sir, please.
So in case the internet is not working, will that car will work?
Yeah.
What my question? Huh?
Yes, sir. Sir, in case internet is not working, it would work, sir.
It would work.
Yes, sir. Because it will have the data would be stored inside the microcontroller, and it would work because it would, the main cause of is that it should have the GPS location. If the GPS is working, then it would work without the internet also, but the data would not be accessed through at the remote location. This is the main disadvantage if the internet is not working.
No question to you. Just want to say congratulations. Just keep it up. Thank you very much.
Thank you, sir.
Thank you, dear Pushpant. Next is Arzu. If Aditya is there, he can be the next one. Otherwise, Rajesh sir, you will be next. Thank you.
A very good afternoon, everyone. This side Arzu, and today I'll be presenting my paper on agentic AI for cybersecurity. First of all, I'll go through the contents of the slides. We'll be discussing about what actually are the problems in today's cybersecurity era. Then we'll be talking about what exactly is agentic AI. Then about the research questions which my paper addresses. And then the ATHS architecture which I have proposed on the basis of existing architectures. The current day cybersecurity issues basically consist of signature-based threat detection systems. In this, we already have a prototype. Then only we are able to detect the new existing threats. The new threats are still not being detected because of us being unable to detect them due to lack of their signatures. Then there is a limitation of analyst-led SOCs. Today, in today's world, human analysts can generally process 3 to 5 hypotheses at a time, but the actual data being produced or actual number of threats being produced in a day are around 200 to 400 GB daily logs. What exactly now is agentic AI? Agentic AI refers to a system in which different agents come to work together in a continuous model in which we have basically 4 options, like 4 stages. First one is perceive. Perceive is generally referred to as collection of data from over the internet or the network data. Then we have a reasoning module. A reasoning module is generally responsible for analyzing the logs and data and then generating meaningful insights out of it. Then we have an act module. Act module is generally used to detect or we can say analyze the anomalies in the behavior of the system as well as different patterns, analyzing different patterns for threat detection. Then it also gives us, not only it detects, but it also gives us a mechanism on which we'll be able to act upon itself without human intervention in between. At last, we have a learn module. The module learns itself with the help of reinforcement learning over the time, and then it produces meaningful insights and stores it over the database. This continuous improvement helps us to not only identify new tracks or new threats, but also store them in the database for a signature-based identification, which will be further helpful for us in upcoming modules. The 4 basic research questions which my paper addresses is how does agentic AI improves efficiency, scalability, and adaptability of threat hunting? Then we have how different technologies are applied in threat hunting agent designs. Then we have how do autonomous agents detect zero-day vulnerabilities without prior signatures. And the last one we'll be talking about is multi-agent system coordinations. When we talk about efficiency, scalability, and adaptability, efficiency generally refers to us how much we can detect on a day-to-day basis. When some human analyst detects a threat, the efficiency is very low. But when we use automated systems for it, the minimum time to detect is approximately reduced to 43%. When we talk about scalability, we would need a number of human analysts for analyzing only a bunch of problems, which will may not be even half of the total threats produced in a day. But when we do it autonomously using agentic AI systems, it can increase to 10x due to its autonomous behavior. Then we have adaptability. Human analysts may require to train themselves over the time for human analysts may require themselves to train over the time to detect new errors or be consistent about them. But our system, which learns automatically on day-to-day basis, does not require such training period. Then we have different technologies we use for threat hunting agent designs. First of all, we have supervised learning. Supervised machine learning is generally used when we need to detect the known errors or known threats in the system. We use unsupervised machine learning when we need to discover attack patterns which are not known to us yet. Then we have reinforcement learning. Reinforcement learning is basically learning over the time, learning over the period about the new threats and analyzing them for further interactions. Then we have LLMs, which are generally used for high complex data, which might not be very suitable for human analysts. Then we have game theory. Game theory generally presents us with an attacker and defender model, which not only attacks on the other systems who are causing threats, but also defends our system for further such attacks. Then we have graphical neural network. Graphical neural network generally analyzes the topology through which the error has occurred in the system or has entered into a system. Now, what are exactly zero-day vulnerabilities? Zero-day vulnerabilities refers to the threats which come on day-to-day basis and does not give even a single day for the human analyst to analyze it and already causes the disruption into our systems. We basically have three different technologies or three different methods of analyzing zero-day vulnerabilities. First one is behavior anomaly detection. In this, our system detects abnormal behavior in case of some scenarios and matches or analyzes it along with the normal behavior which it would have performed when the error was not there. Then we have few short learnings. Our agentic AI system only needs a few examples or only a few set of threads to learn a new signature. Then we have RL optimized deception. RL optimized deception refers to making hypotheses around different scenarios where the error could have occurred and then finally proving which one of them is actually the correct one. Now we have multi-agent system for autonomous responses. Similar to in healthcare sector, like we don't have a single doctor operating on all type of operations. We have specialized persons in every scenario. Similarly, in agentic systems, we don't give all the work to a single agent. We try to divide those work in different agents over the time. We have few specialization agents. First one is scout agent, which is responsible for collection of data. Then we have analyst agent, which tries to analyze the data collected by scout agent and provide meaningful insights. Then we have forensic agents. Forensic agents are generally responsible for analyzing over a period of time that how and why the error has occurred, how it has propagated through the whole system. Then we have threat intelligence systems. These are used to create different kind of hypotheses and proving them if that was the actual reason or not behind any threat. Then we have response agents, which are generally used for responding in place of humans on the basis of their critical thinking. Also, while maintaining or while using multiple agent systems, we need to coordinate them in a meaningful manner. Coordination here can be done through three basic protocols. First one is blackboard architecture, in which we provide same memory to all the agents so that they know the data they are working on is exactly the same. Then we have contact net protocol. In this, the data is or the task is allocated to different agents on the basis of their capabilities.
2 minutes.
Last. Then last we have the Bose protocol. In this, all agents are connected to each other in peer-to-peer manner so that there is no single point of failure at any given point of time. Then